Plastic processing technique from e-waste. Teknik memproses plastik daripada e-waste. Saya Nur Azharuddin Husni bin Hajiruddin daripada Institut Kefahaman Islam Malaysia. Processing plastic from e-waste can involve various techniques. Here are several common methods along with their advantages and disadvantages. It is important to note that the choice of recycling techniques depends on factors such as the types and condition of the plastic waste, the desired output, economic feasibility, and environmental considerations. Each technique has its own benefits and limitations, and their suitable varies depending on the specific circumstances and goals of the recycling operations. It is important to note that this process can vary in their specific technique, depending on the technology and equipment used. Each method has its own advantage and challenge, and the selection of a particular recycling approach depends on factors such as the type of plastic waste, desired output, economic viability, and environmental considerations. First about a mechanical recycling. Advantages involve sorting, shredding, and reprocessing of plastic, which can be cost effective and energy efficient. It helps recover valuable plastic material from e-waste, reducing the needs of virgin plastic. For the disadvantages, limited applicable to certain types of plastic due to contamination, additive, or complex composition. Mechanical recycling may result in degraded plastic properties, reducing the quality of the recycled plastic. Process: sorting and separation of e-waste plastic components based on their polymer type, size, and other characteristics. Shredding and granulating the plastic waste into small pieces, followed by melting and reprocessing to create new plastic product. Second, chemical recycling. Advantage: convert plastic waste into chemical feedstock or fuel through process as pyrolysis, depolymerization, or solvolysis. Offer the potential for recycling mixed or contaminated plastic that are difficult to mechanically process. For these advantages, require advanced technology and energy-intensive processes. Chemical recycling can generate emission and waste products, demanding proper management to minimize environmental impacts. Process involve converting plastic waste into chemical feedstock or fuel through various methods. Pyrolysis applies heat in the absence of oxygen to break down plastic into smaller molecules. Depolymerization breaks down polymer into monomer using chemical process. Solvolysis uses solvent to dissolve and convert plastic. Feedstock recycling. As advantages involve converting plastic waste into raw materials for the production of new plastic or chemical. Enables the recovery of chemical building blocks of plastic, contributing to a circular economic approach. For the disadvantage, requires specialized facilities and technologies. The process may be limited by the presence of impurities or the need for careful sorting and separations of different plastic. For the process, convert plastic waste into raw materials suitable for the production of new plastic or chemical. The waste is treated to separate impurity, and then the plastic is transformed through process like cracking, catalytic reforming, or gasification into feedstock. Number 4, thermal conversions. The advantage: use the high temperature process like gasification or plasma acts to convert plastic waste into energy or syngas for electricity generation or chemical synthesis, can handle a wide range of plastic type and mixed waste stream. For the advantages, require high capital investment and complex infrastructure. Proper emission control and waste management are necessary to mitigate environmental concerns. This process involves the use of high temperature process to convert plastic waste into energy or syngas. Gasification uses heat and controlled amount of oxygen or steam to convert and waste into syngas. Plasma gasification uses plasma generated by an electric arc to break down the waste. Number 5. Biological recycling. As for advantage, utilize biological processes such as enzymatic degradation or microbial fermentation to break down plastic waste into simpler compounds. Offer a potential sustainable and eco-friendly approach to plastic degradation. For these advantages, biological recycling techniques are still under development and face challenges related to scalability, efficiency, specificity for certain plastic types. For the process, utilize biological agents such as enzymes or microorganisms to break down plastic waste, and enzymatic degradation involves the use of specific enzymes to break down the polymers. Microbial fermentation utilizes microorganisms that naturally feed on plastic waste to degrade. And then the last one is about the hybrid approaches. For the advantage, combine multiple recycling techniques such as mechanical and chemical recycling to maximize plastic recovery and address specific challenges in waste processing. For these advantages, hybrid approach often requires significant investment and complex operational integration of different technological. About the process, combine multiple recycling methods to optimize plastic recovery. For example, a hybrid approach may involve initial mechanical processing to sort and separate plastic waste, followed by chemical or thermal process for further breakdown. Okay, the last one is about the reference from the Journal Plastic and Electronic Waste Review. Plastic waste from electrical and electronic equipment, recycling of waste, electrical and electrical equipment, plastic, and also Journal from Process Method for Recovery of Waste, Electrical and Electronic Equipment, WEE Plastic, and then Journal Pyrolysis of Plastic from Waste, Electrical and Electronic Equipment, WEEE Review, and from Journal Recovery of Plastic from Electronic Waste by Physical Separation Method, a review, and Sustainable Recycling of Wasted Electrical and Electronic Equipment, Plastic, and Journal for Recycling of Plastic from Waste, Electrical and Electronic Equipment, and last one, Selective Dissolution for the Recovery of Polymer from Electrical and Electronic Waste. And then Resource Recovery from Waste Printed Circuit Board by Supergravity Technology, Journal from Chemical Recycling of Plastic from Waste, Electrical and Electronic